Okay, so let's see what we can come up with as far as information. Let's start with growth or decay. I think we could answer that without a graph. How could we probably do that without even seeing a picture? Okay, pay attention to the reflection, right? This is this normal graph, and I'm not going to graph the whole thing by hand. I would rather not. With that negative 0.1 there, that's a pretty tight horizontal stretch. So I don't want to graph this completely by hand. But what I do want to know is which way is it going? Well, 3 to the x would go up to the right. But then if I reflect it over the y-axis, then it's going to go down to the right. So that negative exponent is going to cause decay. Okay. It says graph this function and find the appropriate window. Based on that wording, how is this wanting it to be graphed? By hand? Calculator, right? You find the appropriate window. That sounds a whole lot like a calculator question. So let's do this function in the calculator. And let's talk about an appropriate window. If I just push graph, obviously what happens? I don't see anything. Well, why not? I don't, actually my window's weird anyway, but I don't see anything. Do you see that vertical stretch of 100?
Yeah.
What does that mean, my 0, 1 point? Where is it? Instead of being at 0, 1, it's at 0, 100, right? So my very first point has a y value of 100. Do you see why I can't see it? Because it's stretched way up to 100. That's the first point, and then it's going to do what? Drop. So I'm going to change my y max to be 110. It doesn't need to be a whole lot more than 100 because it's dropping, it's decaying. Okay, looks pretty good. I'm only going from 0 to 10 on my x's. What would you suggest? Go out farther on the x-axis as well. Someone said 100. Let's try it. Let's see. That's plenty to get a good picture. Probably wouldn't even have to go that far. That's fine. Then it would be growth. Right, because you'd have 2 reflections. Be careful. You have to also look at the base, because remember, if the base is 1/3, then that's a decay to begin with, and then if you reflect it, it would be growth. So it does matter what the base is, what your base function looks like. But if it's a whole number, or a number greater than 1, and then exponent's negative, then it'll be decay. Did that make sense? Okay, so I'm going to graph this. I'm going to start with this being 0, 0 down here. And we'll make this 100 up here. So I start up there, and I go down. You can decide where you want your scale to be, how far out you want to go on your graph, on your paper. I don't know. If we go back to the calculator and look at the table, if I plug in 10, I'm at 33. So you could use that to decide how to graph it, right, to get a good sketch. Let's see. At 50, I'm really, really small. So I think I'll go to 50. on the x. So I'm way down here. Let's see. 1, 2, 3, 7, 8, 9, 10. So I'm counting by fives. At 10, what did I say? I was 33. Somewhere up in here. You don't have to be perfect. Just a sketch that shows that you graphed it. You don't have to do 3 points on this. Just a decent sketch will do. Okay. So I did X window from 0 to 100, and I did Y window from 0 to, no, I did that backwards. I did X from 0 to 50, Y from 0 to 100. Is this the only right answer? Absolutely not. You could have 100 different answers there and be correct. The big thing is that you need to be able to see the picture. Does everyone understand how I got the picture using my knowledge of transformations? Even though I didn't want to graph this by hand, is it still handy to know transformations? So yesterday you may have been like, oh, why would I ever do this? You probably won't ever do that completely by hand just for the fun of it. But knowing by hand can help you figure out how to graph something that you may have a hard time getting your calculator to show you. Because you have enough knowledge, background knowledge, to pick out, well, okay, this is going to be really big because I have a vertical stretch of 100. So you have an idea of where to go. Find the value of y when x is 8. What's a quick way to do that? Good. Use your table, type in 8. 41.524. The other way to do that is if you're on the graph screen, you can go to second trace value and type 8 for x there as well. Either way, both work great. 41.524. What is the x value that gives you a y value of 20? Unfortunately, your calculator is not quite as good at finding that. This is what I want, right? I want to know what the x is that gives me a y value of 20. This is an equation I don't know how to solve yet. We'll learn how to solve this equation, but not today. In fact, about a week from today. So we still got a while. But I would argue you can solve anything in this class. How? Even if you haven't learned how to do it yet. In the calculator. How? Put one side in y1 and one side in y2 and find the intersection. I already have, actually I would do that opposite because I already have the other one in y1. Leave it there. So I'm going to go back to my y equals, and I'm going to put 20 in y2. Oops. Okay, any questions about that so far? If I have a good graph, which I do because I chose a good window, then I see the intersection already. And how do you find intersections? Second trace, number 5. Push enter 3 times. So you have no idea how to solve exponential equations, yet you just did. So it's amazing how the calculator can help you use it to your advantage. So x is approximately 14.650. Okay, any questions about that one?
So, I have a question.
Sure.
Like on the first one when it was talking about decay, since the exponent was negative, it's decay.
Be careful about making that across the board assumption. It does matter what the base originally was. If the base was originally a number greater than 1, then yes. Remember, with a third, 1/3 to the x starts out as decay. So if you reflect a function that starts out as decay, then it would become growth.
So like if it's less than 1, then it was negative,
Right. Now, that being said, most of the problems we're going to deal with are going to have bases that are greater than 1. So, yes, if you're careful, you can make that, but just be careful. Look at the base function first. So 3 to the x is originally growth, and so when I reflect it, it becomes decay. Okay, so today we're going to look at some applications. Several of you said that you had never seen E before, so we'll talk about the number E a little bit. Yes, I did say the number E. That was not an error. E is a number. It's kind of like pi. Pi is 3.14 E, if we look at a calculator. And I will teach you where E comes from on a later date. It's a pretty important number. There are two ways to get to it. You can go to second ln, and it gives you e to a power. So if I do e to the first, I get 2.708. That's the button you're going to want to use most of the time. If you go to second divide, you get just a plain e. You can use that, but most of the time when you use e, it will be in the context of an exponential. So you will probably want the exponent on it anyway. So it skips a button if you use second ln. So that is the number e. It's a very important number. Again, I will show you where it comes from on a later date. Today, the word problems that we're going to be looking at, they're going to set them up for us. Later, we will learn how they got this set up. But today, we're just going to take a function that they gave us. It just happens to be exponential, and answer questions about it. So this is the bulk of what your homework looks like tonight. So it says, graph the function in your calculator on an appropriate viewing window. How would you do that? What am I going to be thinking about when I graph it? Remember, E is about 2.7. So I'm going to go to my calculator and type it in, first of all. Step 1. Okay. My vertical stretch is 87,000. Does everyone agree? The exponent is positive. So that means I'm going up, right? Because E is a number greater than 1. So this is exponential growth starting at 87,000. So help me with the window here. Okay, would you agree the lowest value I'm going to have is going to be 87,000? For the y value, the lowest y value, because then I'm going to go up from there. So on my y min, I'm going to put 87,000. Y max, I'm going to get bigger than that. I don't really know how much bigger yet, so I'm going to guess at that part. I'm going to do 100,000 or something. And I'm going to go back and do my x's just from -10 to 10. And you could even really do 0 to 10 if you wanted to, because this is population. If you read the question, we're not going to care about negative time. And I'm going to push graph. Did it do okay? Could it stand to get taller? So you might change your window to be 500,000. I don't know. Well, I guess kind of big there. Then it kind of looks like I could go out farther. So we could play with this all day long. We'll go read and see what other questions it asks. I went ahead and made my x's 50. That looks like a pretty good sketch, doesn't it?
Yeah.
Pretty good exponential sketch there. Okay. On your homework, show me that little sketch. It doesn't have to be pretty. Just show me that you did graph it. What is the population in 1998? Well, what is T? What does it say T is?
Number of years after 1998.
Okay, so what in 1998, what's T?
0.
0. Does everyone agree?
Yeah.
Okay, so let's go find out. Calculate the value at 0. It's 87,000. Does that make sense?
Yeah.
Because we knew that already. We could have answered that without a calculator. Okay. Is the population increasing or decreasing? Increasing. We could have answered that before we graphed it, couldn't we? What is the predicted population in 2013? Well, what am I going to find? What T value is 2013? 15. How'd you get 15? Just count. Good. 2013 is 15 years after 1998, right? So I'm going to go find the value. You can either use your table or you can use your value button. It's 140,598. 0.47. So yes, you can round that to the nearest whole number since it's population. That's fine. 2020, what am I going to put in for T? 22, right? I'm going to skip doing that just for time. I think you can do that. How will you find when the population is 100,000? How will you do that one? Good. Go to y equals and put 100,000 in y2. And do the intersection. Okay? Any questions about how to do that? And then second, trace 5, enter 3 times, and you get 8.35. Is that what that says? I think it is.
That's like 8 years after.
Yeah. So what year would that be?
2006. In the 3rd month.
Okay, last one, average rate of change. To do average rate of change, that is a slope. Anytime you see average rate of change, that means slope. So I'm going to find the y value in 2020, which I had done in part E. I'm going to find the y value in 1998, which was 87,000. So I don't know what this number was, but and then you're going to divide by what, 22? Where did I get 22? That's the difference between 2020 and 1998. Okay, does that make sense how you do that? I do need the y value here, and I didn't find that I could. It was 92750 with some decimal points. 039. So subtract that and divide by 22 is how you find average
92,000.
rate of change.
That's less than it was in.
No, because it was 87,000.
I thought it was 160,000. 2005. That was for.
That was 2,000. You're right. You're right. That was the wrong value. Okay, this is your homework. Any questions? So today is kind of calculator work, mostly working with exponential functions, find values. Yes. Okay, cool. I still have you down. Anyone else need a calculator for today? Tonight's homework is calculator work. Anyone else need one?